That's not right, is it? I didn't update these. Yeah. So the handouts I've given you, the due dates for the homework assignment is on the 13th, and then the project is on the 20th. And so the homework, it's not posted on Blackboard yet, but it's going to include the price, demand, and break-even stuff that we're going over today, as well as some content that's going to be covered on Thursday of this week and Tuesday of next week. So we've got some time before that homework number 9 is due. I've gotten some good questions on the project, and so let's take a moment to talk about that. So I got some questions about the project, and so I wanted to address specifically the issue of the money that you get during retirement, because everybody has a different amount, but the retirement amount that is mentioned, let me pull up the file here. All right. So this retirement income, this is the amount of the retirement income today. So for instance, Sean has $2,400 for his person that he's analyzing per month today, and then it's going to be growing at 1% every year. So what that means is if the person retired at the end of the first year, then their monthly income would be $2,400 per month times 1.02, because, excuse me guys, I have to take this, it's regarding my son's leg.
The wind blew the damn storm door off my house.
Blew what off your house?
Like, you know, the storm door, like the glass door?
Yeah.
It like snapped it off, and my wife called me, and she couldn't get it shut, so that's why I was trying to get down, like, I had a class, I'll fix it.
Yeah, the door's still there.
Yeah, the real door's there, I guess it might not been shut all the way or something, I don't know. But it like ripped it out with brick balls, not with a replace the brick ball, it's just.
Not bust the door?
Nah, like cause it's door recessed, but it might scratch it a little bit.
Yeah, you might take supply management. Supply management. I had a question, you're doing the coursework only option. For your masters? You said I'm not doing the what? The coursework only option for your masters. Are you doing a project? I did the
Exam?
yeah, the exam.
So he did course only.
Coursework only. It was, oh, that's what it's called?
Yeah.
Yeah, it's like old classes.
So do you get to pick which exams you take and which classes?
So it's one exam with 22 questions, and you get, there were 19 questions, and you pick 5 questions for those 19.
I don't understand how there's
Super
19
easy.
questions.
Oh, okay, so you don't pick, you don't technically pick which grade it goes into. They give you the full, and then you get to pick 5 or 3 or whatever.
Sorry guys. All right. So what I was saying about the retirement income is that this is the amount in today's terms. And so, like, if someone retired at age 25, which wouldn't that be nice, but they're not. Like, it's just that the retirement income is set now, and it's going to be increasing at 2% per year. So you need to find out, for example, if the person's retiring at age 67, how much are they going to be earning in retirement at age 67? It won't be $2,400 per month.
Okay, so year 0, it's $2,400 per month.
Yeah.
It grows by 2%, but you start from year 0.
That's right.
Okay.
Yeah. Now, the other thing I wanted to address, Victor had the question about the income growth. So, let's say the person that Sean is analyzing makes $62,750 for their first year of work. So they're working from time 0 to the end of the first year, and then let's just say for simplicity's sake that they get a lump sum of $62,750. They get it here at year 1. And so if the income growth that we want to find out for the end of year 2, it's going to be this data. The 8.5% is how much more they make at the end of year 2 compared to what their year 1 income growth was. And so, for example, this amount, 1.9% for year 1, that doesn't necessarily apply to anything that you're going to need to calculate, because you're calculating that they made, let's see, we're looking at Angelica's person here, $52,500. They get that at the end of year 1. And so to find out how much they get at the end of year 2, it's 3.2% more than 52,500. So does that make sense? So this first income growth is redundant. Now, the rate of return on savings, this isn't redundant because everyone starts off with some savings balance. And so if you start off with a debt, then your debt is going to be more at the end of the first year. If you start out with savings, then the savings amount will be more, and so you will use this amount on the first row for the savings, but not necessarily for the income growth, because we're assuming the end of period assumption. Okay, so before we move on from the project, are there any other questions that have occurred to you as you've been working on it? Ben?
So the savings that you start with, like you're in year 0 and you have that savings, but you don't start accruing interest to the end of year 1, right?
Well, that's when the interest would be paid. You're accruing interest over the period.
Yeah,
So
okay.
it's from time 1 to from time 0 to time 1 that the interest is accruing, but then it's paid out. It comes into the account as a lump sum in here in this location.
Would it be correct for me to, like, when I'm setting in my spreadsheet and I have like a savings balance
Mhm. Yeah,
column,
yeah.
in year 0, if my savings balance was $10,000, and that $10,000 go there, and then in year 1 it would be that plus the interest off that plus my savings.
That's right.
Okay.
Yep. Other questions? All right. Angelica, is that a cigarette? No, I'm just joking. I was running a marathon one time with a sucker in my mouth, and people kept looking, and they thought it was a cigarette, which is like the most unlikely thing ever, right? That you're running a marathon and smoking. It made me think I should start running with a cigarette.
Did you hear about the Chinese man who did an entire marathon while chain smoking?
Yeah. And he got a pretty good time. I think he did like 3.5 hours or something. That's fast.
Wild.
Yeah. Pretty good. All right. Well, keep working on the project, and as your questions arise, let me know. I want to help you, but it sounds like some people are almost done with the project, incredibly. So, all right. Today we're going to be working on price, demand, and break even. And so this is kind of interesting concepts that apply to a lot of economics classes, but it's also relevant in cases of engineering because we're going to be facing the questions of how much it would cost to increase production capacity and the non-linearities of costs. You know, like sometimes there's something known as an economy of scale, which is simply that when you buy things in bulk, they can occasionally be cheaper than if you're buying a small amount. You know, if you buy 1 pound of potatoes, then your cost per pound is going to be higher than if you buy a 25-pound sack of potatoes. And so that's kind of a little bit of background on why we're looking at these price, demand, and break-even questions that sometimes are just the purview of economists, but it has engineering implications as well. And so I think it's important for us to understand these principles. One of the Thanksgiving traditions in my family is to go and buy a newspaper, because the newspaper that you get on Thanksgiving is thick with advertisements from all the stores that have like their Black Friday deals. And it used to be even bigger before online shopping. Like now, online shopping, there are some Black Friday and Cyber Monday deals. I'm sure everybody's aware of that. But you'd have these printed ads that would be in the Thanksgiving newspaper when people have nothing better to do than like watch a parade, watch a football game, eat turkey, and then go through the newspaper and plan out all the shopping that they want to do. And so some of these really low prices have the effect of attracting quite a lot of attention. And so it generates demand. So if you look, these people are lining up at night in the dark, and you can see the people who've been at the front of the line, they're sitting down in chairs and have reflective blankets and everything, trying to keep warm and comfortable through the dead of night, because they want to be first in line to get the cheap flat screen TV, or maybe like, I don't know, a new Xbox or something. So everybody's already familiar with the idea that lowering prices increases demand, but there are several other second order consequences of that we need to be aware of. Now, Amazon has generated quite a lot of demand, sometimes by lowering prices at first, but then by becoming a monopoly in a lot of households, where when you join Amazon Prime and you get in the habit of purchasing things from them, whether it's subscribe and save, or just the notion that you've got free shipping that you want to use, or just how easy it is with the app. Sometimes it's their low prices that draw people in, but sometimes it's just because it's all that they think of as shopping with Amazon. But regardless, they've been so successful in increasing their share of the market that a lot of in-person retailers have gone bankrupt as a result. So Toys R Us is an example of that, where they filed for liquidation, and the Toys R Us building here in Huntington, well, I guess it's in Barbersville. I remember I used to take my kids there to shop for toys, and now it's like an empty warehouse. For a very brief period, it was like a trampoline park, but COVID killed that pretty quickly. So now I think it's just maybe for a couple of months in the fall, it's like a Halloween store or something. Yeah. So what we're talking about today is demand and how that is generated and what the effects of demand are. So by demand, what I specifically mean is people wanting to purchase an item, and so the way that we can control that, the independent variable is through the price, and the dependent variable is how people react to the variable that we could control, which is the price. And so we only indirectly control the demand by lowering the price, and sometimes they'll intentionally decrease demand by raising the price. And so if you think about what's happened because of a lot of supply chain shortages, like for new cars in particular, like a lot of car dealers are able to charge an extra premium for really desirable cars like the new Corvette, or for certain trucks that are like performance packages. They'll tack on an extra $7,000, an extra $10,000 to turn people away who ordinarily would be willing to purchase that item, but they don't have enough to sell anyway. You know, if a dealer is only getting 2 of a certain vehicle per month, and they live in a market where they could sell 5 at the sticker price, one of the way that they can find out who really wants the item the most is keep increasing the price until their demand matches the supply. So rather than just selling it to the first couple of people who come in off the street at the sticker price, the dealer figures, why not raise the price? And then they control the demand by increasing the price. So the relationship that we all instinctively know is that if the price increases, demand decreases, and that if the price decreases, the demand will increase. And so we could graph that, and the simplest way of graphing that would be just to assume a linear relationship. So think about if this curve shows that what we already know instinctively, that if you have a high price, so high on the y-axis gives us a low demand. So the x-axis here is demand. So far to the left means There isn't very much consumer demand for the item when the price is high. And when the price is low, what we see is a large demand. Now, it could be curved in some way, or it could be flat, but the point is that increasing price decreases demand. Now, there's some important definitions here, and if we extend this line and intercept it with the vertical axis, that's going to be an important factor that we want to be aware of. So if we extend the curve and we intersect it, what that means is there's a certain price at which there will be no demand. So that cutoff point, the price that nobody wants to buy the item, and if you go a little bit lower than that price, now there finally is some demand. So for example, a Ford Maverick truck, nobody would buy it for $2 million. And nobody would buy it for $200,000. But there might be somebody who would buy a Ford Maverick truck for $50,000. Maybe in the whole country, maybe there's one person who'd buy it for $50,000. That's probably there's somebody who'd buy it for more than that. But there's the first cutoff point. What we label that is, in this formula, is A. Now this formula here is saying the relationship between the price and the demand. And it's kind of interesting because it's turning on its ear what we were just talking about with independent and dependent variables. What we were saying on the earlier slide was that demand is the thing that is independent. The price is independent and the demand is dependent, because the demand depends on the price. And so what this is showing is that if you have a low price, then there would be a higher demand. And so there's a certain cutoff point, A, that tells us the price at which there's zero demand. And then the slope of the line here is what we're going to identify as B, the amount that the demand increases for each unit decrease in price. And so if you lower the price by $1, then how many additional units would you sell? That's B. So unit decrease in price means price is lower by $1, and then it would say that you're going to have B extra units sold across the country. Okay, so revenue means the money that's coming in through the sales of an item. And it's the price that the item is sold for multiplied by the number of units that are sold. So if P is the price and D is the number of units sold, then multiply the two together and you get the revenue. And so remember that we have a definition for price. Price is A, which is the intercept. It's the vertical intercept that is associated with zero demand. And then B is the slope of the line. And it's saying for every $1 decrease in price, how much the demand is going up. And then D is the number of units sold. So if you substitute this equation into the formula for total revenue, we're just going to multiply D by each of those terms. And so D times A minus B times D squared. So this tells you the total revenue that you're going to earn for any number of units. If you sell 0, obviously your revenue is 0. But if you sell 1 unit, you could find out the total revenue for that, and so on and so forth. And the interesting thing is that if we graph the demand and the revenue, it doesn't just keep going up. It reaches a maximum point. Now think about why would that be the case, that if you're selling more and more items, how come the revenue is getting lower when you get beyond some certain point?
You're selling it too cheap.
You're selling it for too cheap. That's how you're stimulating the demand, is that you're lowering the price, remember. And so what's happening beyond this maximum point is that in order to stimulate the demand, you've lowered the price such that you're actually having less revenue coming in, because each unit is being sold for less and less and less. So you could be selling a lot of units, but you have less money coming in. So let me ask you, on this graph, where do you want to operate? How many units do you want to sell?
When demand and supply intersects each other.
When demand and supply intersects each other. Okay, that's true. So where is that on this graph? We don't know just by looking at the revenue graph how many units we should sell. And a lot of people mistake maximizing revenue for maximizing profits. Like what we've agreed all semester long is that the optimal solution is the solution that gives you the most profits. And so on this figure, we're only graphing revenue. We're not graphing profit. So what's the relationship between revenue and profit? There is a difference between the two. Revenue and profit. What do we have to subtract from revenue to get profit? Expenses, costs, right. So profit is revenue minus cost. So far, this is not a graph that takes anything into account for the costs. So we will talk about that. But a lot of people mistakenly think that what we're trying to do is maximize the amount of money coming in. And what you want to do is you want to maximize the amount of money you get to keep, not the amount of money that's coming in. Okay, so we'll identify that distinction in the data when we work through the in-class exercise. So on the subject of costs, there's two different kinds of costs. There are the fixed costs, which are related to things that don't change depending on how many units you're making. So let's say that you own a factory that makes iPhone cases. Your rent would be the same whether or not your line is operating. You probably have to pay the same amount to have the machines if the machines are on, if they're operating at 50% capacity, if they're operating at 100% capacity. Those costs are fixed. Maybe the management salary is a fixed cost. But then there are certain costs that are variable, like the cost of the plastic that goes into making iPhone cases, the material costs. Or if you're thinking about the expense of the labor, the people who you are employing to work in the factory, if you are running double shifts, then your labor costs would be double. So certain expenses are variable, others are fixed. And if we look even into a little bit more detail, the variable costs include two components. There's the variable cost per unit multiplied by the demand. So, in the example of iPhone cases, we said one of the costs was the plastic. What if you knew exactly how much plastic goes into each case that you make? So then this lowercase v, the variable cost per unit, would be the cost of the plastic that goes into one phone case. And so your overall variable costs in a certain year would be your variable cost per unit multiplied by the total number of units sold. So that you would find the cumulative variable costs by adding together the individual variable costs per unit. So now here is what we're trying to maximize, profit. You want to have as much profit by having a big difference between revenue and cost. So how do you maximize the difference? Some managers will take different approaches. Some people will try to have big revenue, but there's a lot of movies where like the plot of the movie is that they're coming into some business and they're laying people off, right? They're closing a factory or they're going to cut half of the employees. And in those cases, they're trying to increase profit by reducing total costs. So sometimes they'll reduce cost by giving like early retirement to the most experienced employees whose salaries are the highest. They'll try and incentivize them to leave the company early. Or sometimes people will cut costs by using cheaper materials or trying to eliminate waste and inefficiencies. So we want to have a big difference between revenue and cost. So we don't want to optimize D hat. Looking back at this graph, D hat is what we call the maximum revenue. So the amount of demand that maximizes revenue is this D with a little symbol on top of it, D hat. It's A, remember, which was the intercept with the vertical axis, divided by 2B, which is where B is the slope of the cost line, the demand line. So if that is maximum revenue, D star is optimal demand. It's the demand that gives you the most profit. And so the way that you make the most profit is you try and find the point at which the cost curve and the revenue curve are as far apart as possible. And graphically, that's going to be when their two slopes are equal. Let me just jump ahead real quickly and show you on this figure. You've seen this curve before, the revenue curve from a previous slide. Okay, so C sub F is the fixed costs. Those are the expenses that don't vary depending on how many units you're making and selling. But then C sub V is the variable costs. And what you can see is when you don't make very many items, the variable costs are low. If you make more items, the variable cost is increasing. So the variable cost keeps going up. And then this blue line is the total costs, where you're adding together the fixed and the variable cost. So maximum profit is where these two curves are as far apart as possible. And it happens when those two curves are parallel. Like obviously, like right now, the curves are diverging. So when they're diverging, that means your profits are getting higher. As long as these two lines are getting further apart, then the amount of profit is increasing. But they reach their point of maximum profit here where these two curves are parallel. And so that's what that formula is solving for, is this optimal demand formula is solving for what is the number of units sold at which those two curves are parallel. And therefore the profit is maximized. Okay, the next thing I want to show you on this curve is what are known as the break-even points. You already know about break-even points from our first project. Do you remember when you were selling electricity that there was a certain water flow rate below which you couldn't make money? It was because you had fixed costs that hadn't yet been covered. And then as you increased your flow rate, there was some maximum point, what was it, 7 cubic meters per second, beyond which you were going to no longer make money again. So you already are familiar with the notion that there's both a lower and an upper break-even point. And so think about what these two are representing. It's the first time that the revenue is above the cost. Because here's our cost. If you were to the left of the first break-even point, what that means is that you have very little revenue, but you haven't yet covered the costs. The fixed costs and the variable costs combined together, you're trying to at least make that much money. So D prime 1 is the first amount of demand where you're in the profitable range. But then if you make too many items and you get beyond D prime 2, then you're back into unprofitable territory again, because remember, your revenue is declining. And so your revenue is now below the cost curve, meaning you're not in the profitable range. So we have a formula that we can use to find D prime 1 and D prime 2. Here's the equation. It's a complicated one. So look what it's taking into account. Remember that A is the intercept point with the vertical axis on the price-demand curve. Lowercase v is the variable cost per unit. So that is, what are your production costs per unit of item that's sold? So that's A and V. And those two variables appear inside this plus or minus term as well. And then B is the slope of that curve for the price demand curve. C sub F is the fixed cost, and then B again is in the denominator. So we're going to get some practice using these formulas. Before we move on to the in-class exercise, are there any questions about this figure or the ideas of these definitions? Okay. So here's the scenario that I'd like you to investigate. Let me give you the handout for this. And we're going to, after the first part, you're going to need to do by hand. Was there somebody who didn't get the notes? Did anybody need a copy of the notes from today? Did you get one?
Yes, I didn't over.
Did you get the notes?
Yes. No, not the notes.
Okay, so the scenario is described here. The company produces an electronic timing switch. We know the fixed costs, the variable cost per unit. Here is this equation relates the cutoff point and the slope of the demand curve. So you want to calculate the optimal demand, the maximum profit. So maximum profit, remember, is D hat. Let me write the formula for that on the board. Maximum profit is it's the total amount of money you're going to make at D hat. So optimal volume is D star. So then maximum profit, you basically find out what is the price that causes that demand, calculate the revenue, and also the costs. So for part B, part A is find D star. In part B, calculate total costs, calculate total revenue, and then the formula is there on the handout. Profit is total revenue minus total costs. All right, so let me pause from talking, and parts A through D you'll just do on the paper, and then when that's finished, we'll go through part E together and create a spreadsheet that illustrates all of this. Okay, so A is 180, B is 0.02. The fixed costs are 73,000, the variable costs are 83. So the optimal demand then should be 2425 units. And then in part B, you have to find out what price should they be charging to sell that many units. So if you want to sell 2425, you substitute that demand into the price function, and in order to stimulate that level of demand, you should charge a price of $131.50. So then the revenue you get for that number of sales would be $131.50 multiplied by 2425, and then that shows you that you're getting $318,000, and that would be per month. And then the costs would be the fixed costs plus the variable costs. And so if you're selling 2425 units and each one of the units has variable costs of $83, then you can find out your overall costs. So then profit's going to be the difference between the revenue and the cost. So it's easy to make a mistake when you're putting all this into the calculator, and for that reason I suggest maybe doing it in increments rather than trying to get it all at once. So you'll notice, for example, what I've done is I've written in the substitutions into the formula, but then I find out, for example, what's the value of what's in this first parentheses here. So 180 minus 83 with the minus sign in front of it, it's minus 97. Then plus or minus, and I calculated the value of everything that's in this bracket to the 1/2 power. So then that's 59.74. And then everything in the value in the denominator, negative 0.04. So what we find is that the range of profitable demand is from 932 units, which is the first point at which the revenue exceeds the cost, and then 3918 is the last number of units that's profitable. And any increase in sales beyond that means that they had to lower the price too much to generate the additional demand, and the effect of lowering the price is that the revenues decreased below the costs, the total costs. So that's what we're looking for, is the range of profitable demand. And to give ourselves confidence in these formulas, we're going to explore all this kind of the old-fashioned way using Excel. We're just going to calculate for certain numbers of demand what is the price that's associated with that demand, what's the amount of revenue that's going to be generated, what would be the cost, and therefore what's the profits. So we're going to start up Excel here in just a minute, but before we do, are there any conceptual questions about, I think basically the lesson all boils down to this slide. Like, if you can understand this slide, then you've got the essence of today's lecture. So are there any questions about this slide concepts, or more specifically about the numerical calculations that we've done for this in-class exercise? Ben, you had a long sigh.
No, I feel like I'm going at a really slow pace today. I don't feel like I'm operating efficiently.
It happens. It happens. That usually happens when I didn't have a big enough lunch. You know, when I'm hungry, that's when my
lunch was too big.
my brain's, oh well, yeah, you got to find the sweet spot, right? Because you can also get sleepy and if you eat too much. Yeah. Okay. Well, let's open up Excel, and let me start a new spreadsheet. Okay, so we've got some fixed cost. We've got a variable cost per unit, and I guess maybe I'll also label these. So the fixed cost, I'm just aligning these with the right so that they will bleed to the left. So fixed cost, C sub F is what I've called that. Variable cost per unit, V. Price for zero demand, A. Decrease price by how much to increase demand by 1. That is what the definition of B is. So maybe I'll wrap that and allow it to extend there. Okay, so the fixed cost was $73,000. The variable cost per unit, $83. The intercept of our curve is 180. If we charge 180, nobody will buy any. And then if you decrease the price by $1, then that increases the demand by 0.02, or maybe, let's see, we decrease the price by how much to increase demand by 1? Decrease the price by 2 cents, it increases the demand by 1 additional unit. Okay, so we're going to have a column that's demand, we're going to have a column that's price, a column that's revenue, cost, and profit. So for demand, let's do like 0, 10, 100, 200, 300, and so on. You'll notice I did some odd numbers along the way. I did 500 and then 900 and then 1,000. It's because I kind of already know where some of the break-even points are, and I want to have a specific value that I can play around with to represent that. If you were doing this problem for the first time, you maybe wouldn't know what to use. I mean, you could just do increments of 10, and there'd be a lot of rows, but since Excel is doing the calculations, that doesn't matter. You know, if you just did 10, 20, 30, 40, 50, all the way through 10,000, you know, there's going to be maybe 200 rows or something, but that's all right. Okay, so our price is, remember our equation for price is 180 minus 0.2 times demand. Okay, so the price is 180, anchor that reference there, minus this factor, 0.02, times demand. So this is simply going to tell us what price we should charge in order to stimulate a certain amount of demand. So for example, to have 0 demand, we need a price of 180. And to have a demand of 10 units, we should charge $179.80. Okay, so I'm going to just double click here. We'll continue the calculations down through all the rest of the data. We see what price to charge for a certain number of units. Okay, so revenue is pretty simple, right? It's just demand multiplied by price. So demand multiplied by price gives us the revenue, which we can also double click all the way down through it. Oh, it's not quite wide enough. All right. So now it's telling me how much revenue we make. And it's interesting to see that we do have that trend of decreasing revenue. It looks like our revenue tops out around $400,000, but then it starts decreasing again. So we are going to graph this, but already we can see in the data the behavior that we're expecting to see, which is that the revenue goes up, it maximizes, and then it starts decreasing again. Okay, cost. Remember, our cost is the fixed cost plus the variable. So cost is this 73,000, which I'll anchor by pressing F4, plus it's going to be $83, anchor that reference, times our demand. So the total cost is the fixed plus the variable. So the fixed is 73,000, variable is $83 multiplied by however many we sell. And let me just express this as currency. Okay, so the costs go up and they keep going up. They never reach some maximum point. And then profit is revenue minus cost. Revenue minus cost. So it starts off negative when we haven't yet reached our break-even point. So it stays negative for a while, then there's a certain point at which we're now in the range of profitable demand, and then the profits start going negative again. Okay, so the specific points that we want to check from our hand calculations is, like, what's the first break-even point? And what we found from the hand calculations was that the first break-even point was 932 units. So let's just check here. I've got 900, but if I change it to 931, it's still a little bit negative, you can see. But if I do 932, now we have a positive profit. So 932 units is the first break-even point where we're in the profitable range. And then the last place where we are profitable, I wonder if I could do solver here. Because, well, I could do goal seek and just say that I want the profit to be 0, right? So let me do that. Data, what if analysis, goal seek. And what we're saying is we want this profit to be 0 by changing the demand. Okay, so 3918.53. So if we do 3918, we will have a positive profit. 3918, we have positive profit, and we do 3919, then it's negative. So 3918 is our last profitable number of units. And then the last thing we want to do is we want to find out what's the maximum profit that we can make. So it's somewhere around 2400. For that, we'll try solver, because what we're trying to go for is we want this to be max by changing the demand. So maximize cell E18 by changing A18. Solve. It says 2425, which is the same that we had calculated manually. So 2425. So this one is the optimal demand. This one is the first break-even point. And this one is the second break-even point. And if we just throw together a quick little graph of all of that, we'll find the same kind of shape that we saw in the slides. So let's do a chart. Like, how about a scatter chart where we don't actually see the data points and it's smooth lines. So scatter with smooth lines. And then we're going to add some data to this. And so select data, add a series, and for the x values on the horizontal axis, we're going to have demand. And our first series, let's make it the revenue. So I'm going to name this revenue in the series name, and then select the revenue data. Okay, so we've got that revenue curve. That's good. And we could add another one. So this one would be our cost. And for the x values, again, it's going to be demand. And for the y values, it's going to be cost. Okay, so then this is looking a lot like what we had in that first slide, the slide in the notes. Let me, first of all, let's change the crossover point. I think we do that in format axis, where we want it to be from 0 to 10,000. I don't know why it's going into the negative range there. So from 0 to 10,000. And it's fine for us to be showing the negative values because we're going to have negative profits for a while. So anytime the revenue curve is above the cost curve, this is our range of profitable amounts. So let me change it here so it's just graphing only through 8,000 instead of 10,000. Okay. So let's add one more series to this. So if we right-click on it, select data, we're going to add now the profit. The X values are again the demand. The Y values in this case are the profit column. And this is going to pretty dramatically change our vertical axis. Maybe I'll just go down through 7,000. So through row 24. Okay. So here is the profits. You'll see that the profits only are above the 0 line at those break-even points that we calculated from 932 over to 3918. So we could add a legend to this. And it's going to show our revenue, cost, profit. And then these are the points. I guess to label them, I guess maybe probably we could just put in like manual arrows here. We could draw like that. These are the break-even points. For these two values, break-even points. I think you get the idea, though, about there being some optimal production value for the maximizing of profit. And of course, the tricky part that we were just given is what's the price curve. You know, like in the in-class example that we did today, you were just told up front that this is the formula that relates price and demand. The reality is that's very hard to estimate. And there are economists who can kind of investigate that or estimate it, but we never know for certain what's going to be the relationship between demand and price because there are other things that affect demand, you know, like advertising or substitutions because, you know, if people are thinking about buying one car, they're also willing to consider another vehicle. And so it's not just only the price that controls demand, but other factors as well. But if we do have somebody that estimates the relationship between price and demand for us, then we're able to know quite a lot from that.
Hey, Dr. Wake, can you go over how you added arrows into that chart?
Yeah, what I did was I just went into the Insert tab here and then Shapes. And if you go to Insert Shapes, then you've got different arrows that you can add that way.
That's pretty cool.
Yeah. And you can use that, for example, on your project. You know, on your project, I think it would be useful if you generate just a very brief write-up to explain your assumptions for Part 5. But for the other Parts 1 through 4 analysis, as long as you annotate your spreadsheet and help me understand what you're doing and what your assumptions are and how your calculations go, probably you don't have to do a write-up for Parts 1 through 4. But you could, you know, add arrows and stuff like little notes if you like. All right, well, that's it for today. Hope you have a good afternoon. I'll see you on Thursday.